The senior engineer's dilemma. Why your best habits are your biggest roadblocks in agenting AI. So, traditional software engineering versus agent engineering. And that's the issue that I see in most of my customers, and why AI agents cannot be developed by classical senior developers. Senior software engineers have been the bedrock of digital world. We know that. You build a scalable deterministic systems you rely on. You are the masters of predictability. Nothing that is not hard coded is available and acceptable. So that kind of creates the handcuffs, which means in AI agents era, it's actually blocking you. This isn't an upgrade, it's a paradigm war. And right now, your traditional reflexes are on the losing side. So here are the four fatal clashes. Let's look at the core of the problem. The four clashes where the deterministic mind struggle against the probabilistic machine. First one, text is the new state and you are lobotomizing context. Your career, software engineer, was built on a strict typing, on transforming the messy real world into clean binary structured data. Is the plan approved? A simple true or false is the answer. But AI agents doesn't need a single binary answer. It needs the scope. When the user says this plan looks good, but please focus on the US market, your determined instinct forces you to chop that into a single status approved. You throw away the contextual instruction, you lobotomize the input. In agent engineering, we store the full preserved semantic meaning that text is the new state. We trust the LLM to read the entire statement and adjust its behavior dynamically. You have to stop reducing intent to a handful of fixed fields. Stop being afraid of the ambiguity. Second, hand over control. Your hardware with flow is a limitation now. Microservices, hard-coded flows. You believe that user action must be the defined route. You write the whole flow chart from start to finish. Nothing else is possible. The agent, it's not a glorified state machine. It's a driver that navigates the user's intake. It might go above, beyond the flow, and what you call crash, it doesn't work. AI agent might call it an opportunity, open something new that will lead to completely new opportunities. Oh yeah, you're thinking about hallucination and mistakes. Depends on the content. But you, engineer, must hand over control to the AI agent's brain, which is most of the time not acceptable because you guys were formatted differently. Trust the agent to navigate is something not very acceptable in the old developers if-then world. 3, errors are just inputs. Your reflex is correct for traditional software. If an API call fails, it's an error, it's a crash, that's it. And you gotta roll up your sleeve and start writing code. But agent, however, might be in the middle of the complex, log running an expensive 5-minute task. If the API call is bad, it might go around it and use something else like ready-to-go tool to define the same input. In agent engineering, an error is not an exception. It's just another input. When your world ends, engineers, AI agents start reasoning and looking for a solution. Agents reasoning loop, and you trust it to self-correct and recover. You are managing risk, not eliminating variance. And number 4, unit test is your shield. 0, 1 works, doesn't work. And AI agents is in the middle, not even talking about quantum computing. But how do you write the assertion for write a complete professional summary of the CML? There are infinity valuing answers if you try to mock large language models. You are no longer testing the agents. You are only testing your string that you want to make alive and valid. So you might pivot from the unit test to behavioral analysis. How often doesn't work if that's a really not value for a user? If the crash wasn't an input, what we are going to improve? A lot of open questions which most software engineers doesn't like. The reason I'm putting this video online is because I have been watching a lot about coding, building infrastructure, buying all these expensive tools that are helping classical engineers to build more and more. They call it trustable AI solutions. But in fact, the root problem is that if you think in the binary way, like 0, 1, then the problem is still not solved because you need to start working from the range point of view. The range might be an answer, not 0, 1. The range might be good enough to move forward, not 0, 1. And also, if there is no predefined flow, you engineers see it as the issue, as the challenge, as the problem. While AI will start to look for a solution to build that. Obviously, you got to pick up something at the end, but that's the biggest advantage.